Okay, question. What is Archimedes' principle? Well, the bottom line is Archimedes figured out why things float. The legendary story is this Italian physicist was actually in the bathtub and he figured it out and he was so excited that he ran naked into the street shouting, Eureka! I figured out, why things float. And I'm about to actually teach you what he actually figured out. So let's look at this example where this guy is holding this girl, and basically then he sets her in water, and she actually feels like she weighs less. This is because the water is supporting some of the object's weight. And in this case, it's the woman. I know I like to do this with my children. They normally can't carry me around, but in a pool, they can hold me like this, and they feel strong because they can carry me around. They're not holding up all my weight. They're only holding up some of my weight because the water is supporting some of my weight. So let's take a look at this in terms of a free body diagram. Free body diagram of the woman held out of the water. So basically, let's say this is the woman right here. And basically, we have the woman's weight force acting down. Okay, that's her true weight. And we have the guy holding her up. And basically, what he's providing is the upward normal force. But now let's take a look at the free body diagram of the woman held partially submerged in the water. Her true weight hasn't changed, so I'll draw that arrow just as long. However, here's the thing. The guy isn't supporting as much as he did before. The normal force is much less. Obviously, there's another upward force, and that other upward force is provided by the water. And that's called the buoyant force. F sub B is the buoyant force, which is the upward force the water exerts on the woman. Archimedes' principle is all about calculating that buoyant force. this upward force exerted on the woman, by the water. And it turns out this is Archimedes' principle in a nutshell. The buoyant force is equal to the weight of the displaced water. And what I mean by the weight of the displaced water, consider the volume of the woman that's underwater right now. What used to be there? Right, water. So the water is used to holding up the water that used to be where the woman's body is now underwater, yes? Well, how much can the remaining water hold up? It can hold up as much weight as the water that used to be there. And that's how much buoyant force is exerted upward on the woman. So the weight of the displaced water, you can think of that as the weight of the water that used to be where the object is currently under water. How much does the water hold up? What is this buoyant force? Well, this buoyant force is equal to the weight of the water that used to be where the woman's body is now underwater. The weight of the water that used to be where the object is currently underwater. Hopefully this will become more clear when we look at a sample problem.